Hi, grade 7 students. This week we have a new lecture. Also, this lecture is a revision from last year. We have seen this letter exactly the same last year in grade 6. The title of our lecture is Triangles, Remarkable Lines in a Triangle. The objectives of our lesson: number 1, identify the elements of a triangle. Number 2, know that the sum of angles in a triangle is 180 degrees. Number 3, identify particular or special kinds of triangles. 4, calculate the measure of a missing angle in a triangle. 5, define and draw special lines in a triangle: the height or the perpendicular, the median, the bisector, and the perpendicular bisector. Finally, we will refresh our memory and remember how we construct a triangle according to a given. First, what is a triangle? It's very important to know that a triangle is a geometrical shape. It has 3 sides, 3 vertices, and 3 angles. Let us start with the sides. The side is the line in the triangle. This is the first side, side 1. This is side 2, and this is side 3. So we have 3 sides in a triangle. 3 vertices. First, the word vertices is a plural of the word vertex. So when I talk about one, it is called a vertex. What is a vertex? The vertex is the point where 2 sides intersect or meet. So we have vertex 1, vertex 2, and vertex 3. It has 3 angles. The angle is the space between 2 lines. Here inside, between the 2 lines, this is called an angle. So this is angle 1, angle 2, and angle 3. It's very important to know that in a triangle, each angle has a measure in degrees. This angle has a measure, this angle has a measure, this angle has a measure. There is a very important sentence which says the sum of angles in a triangle is 180 degrees. So if I add the measure of angle 1 plus angle 2 plus angle 3, the 3 measure sum equal 180 degrees. We will start talking about particular lines in a triangle. Which lines can we draw in a triangle? The first line is called a height, or we call it a perpendicular or an altitude of a triangle. This definition, we should memorize it. The height is a segment, I draw it from the vertex perpendicular to the opposite side. To draw a height, we use the ruler which is called the set square. Let me talk about these 2 lines. Always to draw a height or a perpendicular, I should know from which vertex I am drawing and to which side should I draw. Suppose I asked you to draw the height from vertex A. So I ask, which side is opposite to vertex A, standing in facing vertex A? It is side BC. So I bring the set square which you have in your geometrical set. It is the right triangle. The horizontal line in my ruler, I put it on BC, which is the side, and the vertical line in the ruler should pass in the vertex A, and I draw a perpendicular or a height. It is called AM. Now, after drawing the height, I make a right angle. Always in the same way, I draw the height from C to side AB, and I draw a height from vertex B to side AC. After drawing the 3 heights in a triangle, you can see that the 3 heights intersect at the same point. So we say in a triangle, the 3 heights are concurrent. What do we mean by concurrent? They intersect at the same point, and we call the point of intersection of the 3 heights, we call it the orthocenter. So these 3 lines should be memorized. Now I will talk about the median of a triangle, or the median segment in a triangle. Also, we should know the definition of the median. To draw the median is a segment, also it is drawn from the vertex, but not perpendicular to the opposite side. It should be to the midpoint of the opposite side. To draw the median, we use a long ruler. Also, you have it in your geometrical shape. So before I start drawing the median, suppose I am drawing the median of side BC. So I bring the long ruler, I measure BC. I measure it now, it is 8 centimeters. To find the midpoint of segment BC, I divide the measure by 2. So I divide 8 divided by 2 is 4. I mark on the 4. This point, which is M on the 4 centimeter, it is called the midpoint of BC. As you can see here, I put 3 dashes with 3 dashes, which means BM is equal to MC. Now, after drawing the 3 medians in a triangle, also the 3 medians in a triangle are concurrent. They intersect at the same point, and this point of intersection is called centroid or center of gravity. So these definitions and lines with the definition and the lines of the median, they should be memorized. Now we move to the next line. Now I will talk about the bisectors in a triangle. Previously, we have seen that every angle I can draw its bisector. How we draw the bisector of an angle? It is a line that divides an angle into 2 equal angles. We always draw the bisector using the ruler, which is the protractor, the half a circle. What should I do? I measure the angle and divide the measure by 2, then I draw the bisector. Suppose I wanted to draw the bisector of angle CAB. It is at vertex A. So I put my protractor on vertex A, I measure it. Suppose the measure is 100 degrees. So I divide the measure by 2, it is 50 degrees and 50 degrees. Where I mark the 50 degrees, I join it with A, so I get this line is called the bisector. Also, after drawing the other 2 bisectors, the 3 bisectors in a triangle are concurrent. Again, what do we mean by the word concurrent? They intersect at the same point, which we call it the incenter. The fourth line and the final line we can draw it in a triangle is called the perpendicular bisector in a triangle. The perpendicular bisector, we draw it for a side. So side AB has a perpendicular bisector, side BC has also one, and side AC. What is the definition of the perpendicular bisector? The perpendicular bisector is a line perpendicular to the side at its midpoint. So first, suppose I want to draw the perpendicular bisector of BC. I assign the midpoint of BC, so I measure BC using the long ruler. I divide the measure by 2. Suppose BC is 6 centimeters, so I say 6 divided by 2, so this point is the 3 centimeter. After assigning the midpoint, I bring the set square, I put it on BC on the horizontal line, and I draw a vertical line. It should not be from the opposite vertex, it's any line. So this line is the perpendicular bisector of segment BC. Also, for the other 2 lines, we can draw perpendicular bisector where they intersect. We say that the 3 perpendicular bisectors are concurrent. They intersect at the same point. This point, it is called the circumcenter. Why? Because if I wanted to draw a circle around the triangle ABC or circumscribed about the triangle ABC, this point will be the center. So I bring the compass, I put the needle here, I open it as A, and after drawing the circle, the same circle will pass in B and C. Now, what are the particular or special kinds of triangles? The first special kind of triangles is called the isosceles triangle. Also, we should study this definition. Which triangle we call it isosceles? It has 2 equal sides and 2 equal angles. all isosceles triangles has a special vertex. Why is it a special vertex? From where the equal sides are issued, and a special side called the base. The base is opposite to the special vertex. Suppose I have a triangle CBA. I said the triangle CBA is isosceles of vertex C. So the special vertex is C. The equal sides are issued or coming out from C. So the first side is CB, the second side is CA. So CB is equal to CA. AB, which is the side opposite to the special vertex, we call it the base. These two angles on the base, which are CBA and CAB, are called the base angles. They are both on the base. They are equal angles. Equilateral triangle, why? Because also we study this definition. It has 3 equal sides and 3 equal angles. Each angle measures 60 degrees. So triangle ABC is equilateral because CA side is equal to CB is equal to AB, and angle CAB is equal to angle CBA is equal to angle ACB, and each angle is equal to 60 degrees. The right triangle, it has a right angle. So one of its angles measures 90 degrees. Always in a right triangle, the side opposite to the right angle is called the hypotenuse. Again, if I gave you triangle ABC right at vertex B, then the angle at vertex B is equal to 90 degrees, which is angle ABC equal to 90 degrees. Which side is opposite to vertex B? It is side AC. So AC, which is opposite to the right angle, is called the hypotenuse. As you can see in a right triangle, always where the right angle is formed between side CB and BA, these two sides are perpendicular to each other because the angle in between is 90 degrees. The semi-equilateral triangle, has 3 angles, and each angle measures the first angle always measures 30 degrees, the second angle measures 90 degrees, and the last angle, this is a typing mistake, the last angle measures 60 degrees. So each angle measures 30 degrees, 60 degrees, 90 degrees. This triangle, we call it a semi-equilateral triangle. Now, how can we find the measure of a missing angle or angles in a triangle? What do I mean by this? I said that in each triangle, I always have 3 angles. So now I'll give you the measure of 2 angles, and there is an angle which is missing. I don't know its measure. How can I find it? For example, triangle ABC is given, angle ABC is equal to 40 degrees. So the angle on vertex B is 40 degrees. Angle BAC at vertex A is 60 degrees. I should calculate the missing angle ACB, which is at vertex C. Again, I go back to slide number 1, where I said the very important sentence, which is the sum of angles in a triangle is 180 degrees. I should always start with this sentence. So I add the measure of the first angle plus the second angle plus the third angle equal to 180 degrees, sum of angles in a triangle. Now I am given the measure of angle ABC and BAC. So now I replace the given angles and I keep the missing angle. We add 40 plus 60, it is 100 degrees, plus angle ACB is equal to 180 degrees. Now the missing angle ACB is equal 180 degrees minus 100 degrees. So angle ACB is equal to 80 degrees. This is how I calculated the missing angle ACB. Now triangle EFG is right at E. I stop. I ask, what do we mean when we say right at E? So this triangle, the angle at vertex E is right. What do we mean by right? It's equal to 90 degrees. Let's name the angle at vertex E. It is called FEG. So directly I write, since triangle EFG is right at E, then angle FEG is equal to 90 degrees. So I found FEG, it's 90. I still have EGF. This is a missing angle, so I start with the sum of angles in the triangle. I replace the given angles. I add 20 plus 90, so angle EGF equal 180 degrees minus 110 degrees, so angle EGF is equal to 70 degrees. Now triangle ABC is equilateral. I ask, what do we mean by equilateral? So this triangle has 3 equal angles and each angle measures 60 degrees. So angle ABC is 60 degrees, BAC is 60 degrees, ACB is 60 degrees. Triangle KLM is isosceles of vertex M. What do we mean by isosceles? It has 2 equal angles. Who is the special vertex? It's M. So I go back to the name of the triangle to name the equal angles. If M is the special vertex, I hide it. So the equal angles are at vertex K and vertex L. MKL angle equal MLK angle. So I'm given KLM angle equal 40 degrees. So both angles are equal to 40 degrees. I found LKM 40 degrees. Also, triangle MNP is isosceles of vertex P. So the special vertex is P. I have 2 missing angles, PMN and MNP. First, I ask, who are the equal angles in this triangle? Angle at vertex M and angle at vertex N. So PMN equal PNM. But I'm not given any of these. They are equal. So 80 I subtracted from 180, I get 100. 100 is divided between both. So I divide it by 2. Each angle will be equal to 50 degrees. Please practice these 2 slides well after watching and understanding them. Construction of a triangle. How can I draw any triangle? Always to draw any triangle, we will be having a given according to the question. So to construct a triangle, there are 3 cases. First, if I am given the measure of the 3 sides, here I need a long ruler and a compass. The compass is the set you have, is the instrument you have it in your geometrical set, which you use to draw a circle. It is called the compass. So how do we draw? We choose the longest side given and we draw it using a long ruler, or of course we name this side. After that, I open the compass on the long ruler according to the measure of the second side and I draw an arc. What do we mean by an arc? A part of the circle. The same I do with the third side. I open the compass on the ruler as the measure of the third side and I draw an arc. Where the 2 arcs intersect is the third vertex. I connect the third vertex with the first and the second drawn before. I get my triangle. We might be given the measure of 2 sides and 1 angle. So here I should use the long ruler and the protractor. How can I draw? I draw one of the 2 sides using the long ruler. We then assign the given angle using the protractor. After that, we join the angle with the vertex as the measure of the second side. The last construction, we will be given the measure of 1 side and 2 angles. We use a long ruler and a protractor. We use the given side. We assign the first angle on the given vertex. We assign the second angle. The intersection of the 2 lines gives me the third vertex. I'm done with this discussion. Please watch the video well, and if you have any question, contact me to ask whatever you want to ask.